Okay, guys, I'm jumping back into this. This is the Unit 6 review for the final exam. And this is actually a good place to start back up because this is going to be our inequality. So rather than this, there's no equal sign here. We're saying I want all the places where this is bigger than 0. Or in other words, it's saying I want all the places where this is positive. So the first thing I need to do is find the zeros. That's going to tell me where it switches between positive and negative. So I'm going to factor this first. And I'm going to get an x minus 5 and an x plus 4. These multiply to negative 20. They add to negative 1. So my zeros are negative 4 and 5. So let's take a look real fast. I need to test my interval. So I need something less than negative 4. I could use negative 5. If I plug in negative 5 here, I get a negative 10, but I just really care that it's negative. And if I plug in a negative 5 here, I get a negative 1. It's going to be negative. So this whole interval is going to be positive. If I plug in 0, because 0 is between negative 4 and 5, this is going to give me negative 5, which is negative, and positive 4, so that's going to be positive. A negative times a positive is a negative. Okay, and then lastly, if I test something bigger than 5, I'm going to get a positive and a positive. And if I multiply any positive times any positive, I'm going to get a positive. So remember, this problem's asking me, I want all the places where this is greater than 0. We want to think about whether or not we include these. Since there's no equal sign, we don't fill them in. So I'm going to go all the way from negative infinity until negative 4, and then I'm going to pick back up at 5 and go to infinity. Again, I don't include these values because there wasn't an equal sign in the inequality. Number 7 asks us to find all of the zeros, given that the first 0 is negative 3. Well, when we have the first 0, the first thing we want to do is use synthetic division to factor that out. So my leading coefficients here, so I've got my coefficients are 1, 6, 10, and no, it says 0, so this should come out with a remainder of 0. So multiply by negative 3, multiply by negative 3, multiply by negative 3. Fantastic. So this leaves me with x squared plus 3x plus 1. So the next thing I'd ideally be able to do is factor what I'm left over with, but I'm pretty sure this isn't factorable. There's nothing I can multiply by to get 1 that adds to 3, because 1 times 1 is 2. That means I'm stuck with the quadratic formula now. So remember, for those of you who haven't seen this in a while, it's negative b plus or minus the square root of b squared minus 4ac over 2a. So let's use that. My b term is 3, so it's going to be negative 3 plus or minus the square root of b squared, 9, minus 4 times a times c over 2 times a. So it's going to be negative 3 plus or minus the square root. That's just 9 minus 4 over 2. So my zeros are negative 3. Don't forget that one. You don't want to lose that point. And then this is 2 because it's this plus this over 2 and this minus this over 2. Please make sure, like a good way to check that you have the right number of zeros is to look at your leading term. This is a degree of 3, so I should have 3 zeros, and I have 1, 2, 3. Okay, to the back. Okay, number 8's asking us to divide this polynomial by this linear factor. You can do long division, but you really don't have to, because remember, the 0 of this is 5, so really I can just do this. Now, if you want to do long division, you can. It actually showed up on the a practice AP we gave this year. So it's a skill you want to know, but for this test, you just need to figure out what's left over. So I'm going to use synthetic division. I'm going to drop the 3, multiply by 5. Okay, multiply by 5. Multiply by 5. Oh, how convenient. We even have a remainder of 0. So what I have left over is, this is a cubic, so now I'm at a quadratic. So I have 3x squared minus 2x plus 5. If I had a remainder, I would do plus the remainder over, in this case, x minus 5. But we don't have a remainder, so we don't need it. This is what it would look like. So our remainder was 0, but in this problem we don't have a remainder, so we're not going to worry about this term, but that's where it would go. Okay. Number 9 asks us to determine if the binomial is a factor of the polynomial. Will be a factor if there's a remainder of 0. So the 0 of this is 3. There's no cubed term. Drop the 1, multiply by 3, multiply by 3, multiply by 3. Ooh, multiply by 3. If I have to do this in my head, I do 3 times 10, which is 30, 3 times 7, which is 21, 30 and 21 together are this. I don't even have to really add these together. You're going to get 46. But I know that this is not a factor, so no, because my remainder wasn't 0. If this were a problem on the test, you can't just put yes or no. I won't give you credit unless you show some work to justify your response. Okay? Let's simplify this complex expression. I'm just going to FOIL. So 2 times 3 is 6. 2 times I is 2i. 3 times negative 4i is negative 12i. And then negative 4i times I is a negative. These are going to condense. Oop, I even shouldn't put the plus sign. If I have a positive 2i and a negative 12i, those are going to condense into a negative 10i. Remember, I squared equals negative 1. So if I have it negative 4i squared, it's negative 4 times 1. It's the same as adding 4. So now I can combine that 6 and that 4 to get my final answer. Okay. For number 11, we want f of g of x. F is the outer function. Well, f is something squared minus 2. That's the function. It's saying whatever I plug in for x, that's going to get squared, and then I'm going to subtract 2. Well, what are we plugging in for x? We're plugging in g of x. So g of x is going to get plugged in here. So that is f of g of x. This is a good answer. We could also FOIL this out. Which would give me, goodness gracious, 16x squared. We're going to get a minus 4x, a minus 4x, a plus 1, and a minus 2. So you could also leave your answer like this. If this was multiple choice, you could see it written out like this. But if this was a free response problem, I'd probably be fine with you guys leaving it just like that. Okay, number 12. We're going to look at determining if when a function is increasing, decreasing, or constant. So pretty much it's increasing is as you read from left to right, it goes up. It's decreasing if as down, and it's constant if it goes horizontal. So the first thing I like to do is identify the places where there's a change. So you'll notice here we change from going down to up. Here we change from going from up to down. So let's start with where it's increasing. It's only increasing from here to here. We use x value, so it starts at negative 1 and it goes to 1. Decreasing, it's decreasing until negative 1, and then it starts decreasing again at 1 until infinity. There's no places where it's constant. So let's look at this one. Notice I have a change from increasing to decreasing, a change from decreasing to increasing, and a change from increasing to constant. This is increasing from negative infinity until 2, 3, negative 3. So increasing again from 1 until 4. We're decreasing from negative 3 until 1. And then it's constant from 4 until infinity. Okay, so here's my last one. It says determine each 0 of f of x. So let's do that first. We're going to have a 0 at 0. We're going to have a 0 at 3. And we're going to have a 0 at negative 5. It says then determine its multiplicity of each 0. So this 0 has a multiplicity of 1. This has a multiplicity of 4. This has a multiplicity of 3. Okay. Then determine the multiplicity. Okay, decide if the graph touches or crosses the x-axis. Well, odd, it's going to cross. Oops. And at even, it's going to bounce, or it touches. Okay, so now we're going to graph. Now, before I graph, I like to check a couple other things. You'll notice that I have degrees of 1, 4, and 3. The overall function has a degree of 8, because if I FOILed this out, this would be x to the 4th, x to the 3rd, and x. So together that's going to be x to the 8th. You'll notice I'm also going to have, if I multiply x, and then these x's and these x's, there's going to be a positive leading coefficient. So if it's even, and the leading is positive, it's going to be something like this. Remember, it's going to always have one less turn, so as I have 1, 2, 3, 4, 5, 6, 7 turns. So I know it needs to start from the top and it needs to end going up. So my zeros are at 0, 3, and -5. I start up here. -5 is going to cross. Notice it says at 0, we're going to cross. And then we're going to bounce at 3. Now this is a little simplistic, and I'll tell you why. When at this cubic one here, when you cross, it actually is going to cross more looking like a cubic. So here I really should have come in and then flattened out and then gone back out. Should have done this shape. But for this test in particular, I care more about if you recognize it's odd or even and you cross or you bounce. So if you're feeling up to it, you can make this look like a cubic, but I'm not that worried about that for right now. Okay, so cross at 3. Oh, sorry, cross at -5 because it's odd, cross at 0 because it's odd, and then we're going to have a bounce because this degree is even. So there's the Unit 6 review. I hope you guys found this helpful. Don't forget your second part of the final exam is coming up soon, okay?